This lecture is on alkane and cycloalkane nomenclature. Hydrocarbons are substances that have only carbon and hydrogen atoms. For example, the simplest alkane is methane, and to the right is the Lewis dot structure of this molecule containing 4 single bonds between C and H. Naming alkanes is by taking the prefix and adding the suffix -ane. Here's a table showing the first 10 alkanes. The prefixes from 1 to 10 are as follows. 1 is meth, 2 is ep, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. All 10 substances end with the suffix -ane. The most common ways to view an organic molecule are 1. Expanded structure formula, 2. Condensed structure formula, and 3. Skeleton or line angle formula. Let's look at ethane and propane to illustrate each of these forms. Ethane is a 2-carbon alkane, and as you can see, ethane has an expanded structure formula with single bonds between CH bonds and CC bonds. The condensed structure formula has just hydrogen atoms per carbon atom, so the formula is CH3CH3. And some books have lines between carbon atoms to indicate there is a bond between the C atoms. Lastly, under the skeleton formula, in place of carbon and hydrogen atoms, we use one line for a 2-carbon molecule. Propane is a 3-carbon alkane, and as you can see, propane has its expanded structure formula with single bonds between CH bonds and CC bonds. The condensed structure formula has just hydrogen atoms per carbon atom, so the formula is CH3, CH2, CH3. Lastly, under the skeleton formula, in place of carbon and hydrogen atoms, we use 2 lines for a 3-carbon molecule, and note it is bent with each point representing a carbon atom. Key properties about alkanes and cycloalkanes are as follows. Both have molecular shape of tetrahedral with a bond angle of 109.5 degrees, but the difference is the molecular formula. For alkanes, the molecular formula is CnH2n plus 2, and for cycloalkanes, it is CH2 parentheses n with n greater than or equal to 3. In examples 3 and 4 are cyclopropane and cyclobutane. Cyclopropane is a cyclic 3-carbon molecule with a molecular formula of C3H6 in the shape of a triangle. Cyclobutane is a 4-carbon cyclic molecule with a molecular formula of C4H8 in the shape of a square. In examples 5 and 6 are cyclopentane and cyclohexane. Cyclopentane is a cyclic 5-carbon molecule with a molecular formula of C5H10 in the shape of a pentagon. Cyclohexane is a 6-carbon cyclic molecule with a molecular formula of C6H12 in the shape of a hexagon. Naming substituted alkanes can be done by doing the following. 1. Identify the longest parent chain. 2. Number the substituents in order of the longest carbon chain in lowest numbers possible. 3. If you have 2 or more substituents identical, please use prefixes in front of the name of the substituent. 2 for di, 3 for tri, 4 for tetra. Note the prefix of the quantity does not affect the ABC ordering of the name of the molecule. Here are some substituents including CH3 is methyl, F is fluoro, and NO2 is nitro. These substituents will be used for other names of other types of molecules. In example 7, there is a 4-carbon cyclic alkane, so its parent name is cyclobutane. There is a bromo group on carbon 1 and a methyl group on carbon 2, so the IUPAC name is 1-bromo 2-methyl cyclobutane. In example 8, the parent chain is 6 carbons long, so its parent name is hexane. There are 2 methyl groups on carbon 2 and a chloral group on carbon 4. The IUPAC name is 2,2-dimethyl 4-chlorohexane. Use commas only when you have more than one identical group and dashes between the location of the substituent and its name. Here is a review exercise for you to work on. Draw the following compounds. A, 3-fluoro 3-methylpentane. B, 1-methyl 3-propyl cyclohexane. Name the following compounds. Please see the drawings for A and B. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.